Hello everyone, welcome to the Quadratics review video. So we've got our test coming up and I thought we could have a look at a video where we just review the quadratics topic. Now this will be a little bit different to regular videos. I want this to be an active review for you. So what that means is I'll give you a question, say like this: x squared equals 16, and then I'd like you to pause the video and have a go at solving it yourself, and then come back and see what the working is. So there you go, first one, nice and easy to start with. Have a go at solving x squared equals 16. Alright, so we know that the opposite of squaring is to take the square root. Okay? But can we just say that, the square root of 16 is 4? Can we just do that? Well, that is correct, but it's not the only solution. So we've got to make sure that with our square roots we have a plus or minus. Okay, so we have two answers here, plus or minus 4. Alright, have a go at this one. U squared minus 7 equals 0. Alright, we want to add 7 to both sides. Okay, so we're trying to solve for u, so we want to get u by itself on the left. So I've moved that 7 over, and now we want to take the square root of both sides, plus or minus the square root. And so our answer is plus or minus the square root of 7. You should know from your surge topic now that that's something that can't be simplified. Alright, example 3, or question 3. X plus 4 multiplied by x minus 8 equal to 0. How'd you go with that one? Did you remember that when we have two things like a p and a q multiplied by each other and they equal 0, well, either the p equals 0 or the q equals 0, or maybe both of them. So in this kind of question we can set x plus 4 equal to 0, or we could set the x minus 8 equal to 0. And then these are just two simple linear equations to solve now. Minus 4 from both sides on that one. We'll add 8 to both sides on this one. So our answers are x equals negative 4 or x equals positive 8. Okay. Number 4. We're going to do 10, by the way. 10 of these. Alright, number 4. X multiplied by 2x plus 1 equal to 0. Well, once again, we have two things equal to 0. First one is just x equal to 0, or we can set 2x plus 1 equal to 0. Now x equals 0, we don't have to do anything more with that, but the 2x plus 1 equals 0, we've got a two-step equation to solve. Minus 1 from both sides, and then the opposite of times by 2 is to divide by 2. And there we go, our two answers are 0 and negative 1/2. Alright, number 5. Solve x squared minus 3x equals 0. Have a go at that one. Pause it now, have a go at that. Alright, when we look at this, it can be tempting to think about the quadratic formula and solving monic trinomials and all that kind of thing, but it's not a trinomial, is it? There's only two terms there. And do we have a common factor? We do. That's x. So we can drag that out the front, and what is left is x minus 3. And now we've created a question just like the last two that we've done. So either x equals 0 or x equals 3. Okay. Number 6. X squared plus 2x minus 15 equals 0. Solve that for x. Have a go. Alright, well hopefully you've realised that this one is a monic trinomial, and so we've got a process to go through. We want to look at this constant term at the end and see if there are any factors of that constant term that will add to give this coefficient here. So, just focus on factors. You come up with a whole list of factors of negative 15, like minus 1 and plus 15, or minus 15 and plus 1, but neither of those add together to give plus 2. And hopefully you've realised that it's negative 3 and plus 5. They're the two factors we're after. And we can see that minus 3 plus 3 plus 5 does give us plus 2 when we add them. Well, once we've decided on our pair of factors, we can just put it straight into the brackets, straight into this format. X minus 3 times x plus 5 equal to 0. And if you're not sure why that is, what we might do just off to the side is just expand that back out and have a look at why that works. Okay, so we're just going to do a FOIL. Okay, so first term, outer, inner, and last. Alright, so a quick FOIL. Let's see what we get. We get x squared plus 5x minus 3x minus 15. And when we tidy up in the middle, 5x minus 3x is just 2x. So you can see that we got what we started with. Okay, so there's the expansion. All of that just shows why we can factorize like that. And based on what we've done in the previous couple of examples, we can see that x must equal 3 or negative 5. If you're not sure about that, go back and check the past couple of ones that we did. Rewind the video a little bit. Alright, 7. Solve for x. 2x squared plus 13x minus 7 equal to 0. Alright, how'd you go? Did you realise that this one is a non-monic trinomial? So this is a harder trinomial. We can't do the same method that we just did in number 6. In this one, we have to look at the first term and the constant term, and we multiply those two together. So what do we get? 2 times negative 7, well that gives us negative 14. So I'll just put this off to the side. And now it's with this number that we... sorry, I'm just getting interrupted here. It's with this number that we look for some factors. Okay, so factors of negative 14 that add to give this plus 13. Well, this plus 13 in the middle here. Okay, so this one's pretty straightforward. We've got negative 1 and plus 14. Okay, we can see that negative 1 plus 14 does give us plus 13. Alright, so what we do is we take these two factors and we use them to help us rewrite the question with 4 terms instead of 3 terms. So we still have 2x squared, and we still have negative 7, but we're going to rewrite the 13x in terms of a negative 1x and a plus 14x. Okay, so negative 1x and plus 14x. So it's still the same question, but we've now got 4 terms. And now that we have 4 terms, we can factorise in pairs. So we're just going to look at these first 2 to start with. What's something common? X. And when we bring x out the front, we're left with 2 lots of x minus 1. There we go, got there eventually. Okay, so that's the first pair. And then we can look at the second pair, which is 14x minus 7. Just focusing on that pair, what's common? 7. And when we bring it out the front, we're left with 2x minus 1. So the same thing. The same thing is in brackets. And that's very useful because that now becomes our common factor. We've got 2 terms now, and both of them have 2x minus 1 as a common factor. When we bring that out the front, what are we left with? Well, we've got the x here and the plus 7 there. So that's what goes in the second lot of brackets. And now we have 2 things multiplied by each other to give 0, so either the first one is equal to 0, or the second one's equal to 0, or maybe even both. But so we get x is equal to 1/2 or negative 7. There are 2 answers. Alrighty. Next one we're going to have a look at. Oh, sorry. Let's get the right pen, Mr. Laurie. Alright. Everyone's favourite. Solve by completing the square. Okay, completing the square. So remember, this uses the perfect square rule, but sort of in reverse. Okay, so have a go at x squared minus 10x plus 8. And by completing the square, see if you can solve this. Alright, hopefully you remembered that we want to have the x squared term and the x term on the left, but we want to move any constants to the other side first. So let's subtract 8 from both sides. We get x squared minus 10x. Now we're going to leave a gap, okay, because we want to fill that in. We want to complete our square. And on the right we've got negative 8. So we need some number to go in here so that we get a perfect square. And remember that the process to do this is looking at half of that middle term. Okay, so half of that, so 10 on 2 is 5, and then squaring that number. That's the process to go through. Half of the middle term squared, and there it is, there's our number, plus 25. But we can't just add it to the left hand side, because like any equation we have to keep it balanced. So if we add something to the left, we're going to add it to the right. Now the reason we did this is that x squared minus 10x plus 25 is a perfect square. So it can actually be written as x minus 5 all squared. If you're not sure about that, go and revise your perfect square law. And you can also take x minus 5 all squared and FOIL it out, just like what we did earlier. And you'll see that you get x squared minus 10x plus 25. Anyway, on the right hand side, minus 8 plus 25 is 17. Let's take the square root of both sides. So, sorry, stuff's going everywhere. Alright, x minus 5 equal to plus or minus the square root of 17. And then we're going to add 5 to both sides. Sorry, add 5 to both sides. So our two answers are either 5 plus the square root of 17 or 5 minus the square root of 17. Alright, we've got two more to go. Oh, this will be interesting. I need to go down to a new page. Oh, phew. Alright, let's go down to the next page, and we've got two more to do. Number 9. Alright, well, don't want that to go down. Alright, I should just mention quickly, we're not going to look at any quadratic formula questions in this revision, because you guys were pretty good at that. But just remember, you can use the quadratic formula for any question if you want. It's not always the most efficient, but it will work. Just remember that in order to properly use it, your quadratic needs to be in the form ax squared plus bx plus c equal to 0. And then you can go and use or plug those three different values in to x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. The good old quadratic formula. So, yeah. Anyway, back to number 9. For number 9, this is taken out of the chapter review. One of the questions in the chapter review. It's a bit more of a problem that sort of utilizes quadratics, I guess. So here's the problem. We want to find three consecutive, so consecutive means one after the other, consecutive positive integers. Now remember, an integer is sort of like a whole number, but the negatives as well. So 1, 2, 3, 0, minus 1, minus 2, minus 3. So we want to find three consecutive positive integers. See if I can tidy up a little bit. Where the sum of their squares, okay, so the sum of their squares, so if you take each of these numbers and square them and then add them together, the sum of their, getting ahead of myself, this word should be there, the sum of their squares is 50. Okay, so that's the question. Find three consecutive positive integers if the sum of their squares is 50. Have a go at that one. Alright, so the way we want to approach this, first we need to define our numbers. Now we don't know what the numbers are, so let's start with the first one, the smallest of our integers. Let's call it x. And then what is the second integer going to be? Well, because it's consecutive, it's just the next one along. It's x plus 1. And then the integer after that is just x plus 2. So x plus 1, or x plus 2. So they are our three integers that we're going to use. Now the question tells us that each of these integers is squared. So we have x squared, we have x plus 1 all squared, then we have x plus 2 all squared. And these three numbers are added together and the result is 50. Okay, so you can see there's a few perfect squares that we're going to have to use here, expand out. So let's focus on the x plus 1 squared. I'll keep the brackets here just so you can see where everything comes from. The x plus 1 all squared, well, that's x squared plus 2x plus 1. Okay, using our perfect square rule. And x plus 2 squared, well, that's x squared plus 4x plus 4. Now we've got a few like terms. We've got some x squareds that we can put together. We've got some x terms that we can put together. And we've got some constants. Okay, so we can tidy all that up by collecting like terms. We have 3 lots of x squared, 6 lots of x, and plus 5 equal to 50. Let's subtract 50 from both sides. So we get minus 45 on the left and 0 on the right. And now before we go and jump into using the quadratic formula or something like that, because it looks so hard, there's a big number of minus 45, you should always double check when you've got something that's a harder trinomial, double check if there's a common factor. And in this case there is a common factor. We can divide everything by 3. And if we divide everything by 3, what we get is x squared plus 2x minus 15 equals 0. Okay, so now it's a much more manageable question. Also, if you notice, this is the exact same question that we had in number 6. So just skipping a few steps because we already did this one. We found out that if we solve this, we get x equals 3. X equals 3 and negative 5. Oh, wow, this is frustrating, sorry. Okay, 3 and negative 5. Okay, but we're not done, because the original question asked us, what are these 3 consecutive numbers? And they're positive, so x can't be negative 5. So we're going to cross that out. X must be 3, and x was our first of the positive numbers. So if the first of our numbers is 3, then the next 2 numbers are 4 and 5. And that's our answer. And if you have a think about it, I'll let you do this for yourself, but what's 3 squared plus 4 squared plus 5 squared? What do you get if you add all that together? Alrighty, last example. Or last question. Have a go at solving this one. X to the power of 6 minus 7x cubed minus 8. That should be a minus 8 equal to 0. Have a go at that. Alright, this is what we last did in the topic, which is equations that can be reduced to a quadratic. But we need to choose an appropriate substitution. So substitution in this case would be if we took x cubed and just replaced it with a prime numeral, say u. So what does it look like if we substitute x cubed out for u? Well, we get u squared minus 7u minus 8 equals 0. If you're not sure about the u squared bit, just think if we have x cubed but we square it based on our index laws, that's x to the power of 3 times 2, which is x to the 6. Okay, so x to the 6 is just u squared. Alright, so let's solve this for u. Well, we've got some factors of negative 8 that add to give negative 7. That would be negative 8 and plus 1. Okay, so we can say that u minus 8, u plus 1 equals 0. and therefore u equals 8 or u equals -1. But we're not after u, we are after x cubed. So let's put that back in instead. X cubed equals 8 or x cubed equals -1. And then we need to take the cubed root of both sides. Okay, so not the square root, the cubed root in this case. So the cubed root. That's the opposite of cubing something, is to take the cubed root. So when we take the cubed root, we get 2 or we get -1. And there are our answers for number 10. Well, I hope this video has been helpful. I hope it's helped you review the quadratics, and if you've got any more questions, just ask in class. Bye.